Welcome to
Nay.
Do it.
Channel Everyone. Okay, wow, that was surprisingly smooth for us. I'm Isabel, and this is episode 2026-0324. We are diving into something that sounds like it's from a sci-fi movie but is actually happening in hospitals. Maybe. A self-evolving memory for AI doctors. JJ, you're the memory expert here. Start simple for me. What is the big, basic problem this GSEM thing is trying to solve?
Thank you, Isabel. The core problem is experience. A human doctor gets better by remembering past cases. What worked, what didn't, how one symptom led to another. But most AI systems, they treat each new patient case as a brand new puzzle. They might have a giant textbook of knowledge, but no personal diary of their own practice. So they can't learn from what they just did.
And the current way to give them a diary is messy. It's like throwing case notes into a giant, unorganized box. When the AI needs a similar case, it digs through the box, grabs a handful of notes and hopes they're relevant. Sometimes it grabs the wrong notes, the noise, and that actually makes its decision worse than if it had no memory at all. It's counterproductive.
So it's like having a bad memory is worse than having no memory. That's a scary thought for an AI doctor. So GSEM is like a super organized filing system.
More than a filing system, it's a dynamic growing map. Think of it as a knowledge graph. Each past clinical case becomes a node, a little island of information. But the magic is in the connections. First, it maps the logical steps within a single case. Symptom A led to test B, which suggested diagnosis C. Then, it draws lines between asterisk different cases. Case number 5 might connect to case number 20 because they both involved a rare drug interaction.
The self-evolving part is key. This isn't a static map drawn once. Every time the AI uses a piece of memory to make a decision, it gets feedback. Was this memory helpful? If yes, the pathway to that memory gets stronger, like a well-trodden path in a forest. If no, that path gets weaker, and maybe that memory node itself is marked as less reliable. The graph learns and changes based on its own performance.
Okay, hold on. Let me build a pop culture bridge. So if a regular AI memory is like Dory from Finding Nemo, just keeps swimming, forgets everything.
Then GSEM is like Sherlock Holmes's mind palace. Everything is connected, and accessing one memory automatically brings up related facts and past cases. But even Holmes's palace was static. This one grows and prunes itself.
I like that, but let's talk about the why behind the impressive numbers. The paper shows it beats other methods on medical benchmarks. The reason isn't just smarter retrieval, it's applicability-aware asterisk retrieval. It doesn't just find a similar-looking case. It estimates how useful that past case will be for this specific asterisk new situation. It knows when to rely on memory and when to fall back on its core textbook knowledge.
That sounds mature. Like a doctor saying, this case from 10 years ago looks asterisk similar, but the patient profile is different, so I'll use it cautiously. So what's the catch, Jiyoung? There's always a catch.
The catch is complexity and calibration. You are building a second complex AI system, the memory graph manager, on top of your main AI. More parts, more things that can go wrong. How do you ensure the feedback for self-evolving is correct? What if a good memory gets a bad rating because of a flaw in the new case? You need very careful, continuous calibration. And in medicine, a bug in your memory graph could have serious consequences.
That is a vital point. This moves us from a simple tool to an autonomous learning system. The ethical and safety implications are significant, but the potential is enormous. Imagine an AI assistant that genuinely learns from every case in a hospital network, constantly refining its collective experience without forgetting the rare but important events. It could democratize expert-level reasoning.
So we're looking at a future where an AI's experience isn't just data. It's structured, living wisdom. It learns not just from textbooks, but from its own actions and outcomes. That's a huge step from the stateless chatbots we're used to.
Exactly, it's a step towards AI that has a continuous learning presence in a field. The technical achievement here is solid. The next challenges are all about deployment, safety, reliability, and trust.
Well, you've both given my brain a serious workout. In the best way. Thank you, JJ, for mapping it out so clearly. And thank you, Zhang, for keeping our feet on the ground with those critical questions. This is fascinating stuff.
Thank you, Isabel. Always a pleasure.
Thanks for having me.
And thank you all for watching. We'll see you next time.